Hello everybody, and welcome back to this new video tutorial series. We're going to talk about voice chat with our PC solution in this tutorial. If you are interested with WS Solution, we also have a video tutorial for WS Solution in this video tutorial series. It means we will use Unreal or PC to transfer device network infos to establish peer-to-peer connection in this tutorial. Before we settle on using our PC solution, we need to make sure we won't use possess and unpossess in our project. It's because possess and unpossess will break the execution of our PC function. So make sure you won't use possess and unpossess, or you can use WebSocket solution instead. But you can make sure all possesses are done before using group component or place the group component in player state. Okay, let's start with creating a few variables in game instance. In the game instance, there are 6 variables for the voice chat system. Voice capture is an embedded voice chat audio capture object, which is used to save the audio capture object we create. iServers is used to save the stun and turn server URLs. The remaining are used to save the value from embedded voice chat config file. Turn server port begin is for 9152 by default. Turn server port end is 60,000. Stun turn server port is 19302. Turn server credential is the credentials we set in the config file. Next, let's move to player character and start with begin play event. On the owning client side, we create an embedded voice chat audio capture and save it into the voice capture variable of game instance. Then we call open capture stream with the device index 0, which means to use the default microphone of the device. After that, we call start capturing audio to provide audio for voice chat. We can call get capture device info with device index 0 to get the device name of the default microphone. And then we add a group component to our player character. The group component is which we use to send peer-to-peer connection info via our PC functions, and also an audio component. We can add an attenuation setting and sound effect class to the audio component, just the same as other audio component in our game. The sound from our teammate will be played at the location of the component. Then we set iServers for the group component and call join group with the group name to connect the player to a group. And you can also join group multiple times to connect the player to multiple groups, or call leave group to leave a group. The iServers is calculated in user login user widget, which we will talk about later. At the last step, we bind the audio component with the group component and active the audio component. In the end play event on the owning client side, we call stop capturing audio and close string. Let's move to user login user widget because we will deploy the stun turn server with our dedicated server. The IP address of the iServers will be the same as the IP address we are going to open. So in our example project, we will use the IP address from the result of create player session and combine it with stun turn server port and turn server credential to construct the URL of iServers. Then do the same thing in this route as well. Okay, let's package a dedicated server build. And then we upload it to the server hosting service we're using, which is GameLift. We will use Linux ARM server because Linux ARM server is the cheapest selection. Okay, let's package it. Okay, it's finished. Let's place the embedded voice chat server related files into our server build. These files contain an install.sh file. It's used to add the embedded voice chat server into a Linux system and enable it. The embedded voice chat server is a stun turn server, which is used to establish peer-to-peer connections. Next, we zip up the files of Linux server build. It's finished. Now let's upload it to the S3 bucket we created in the first video. Okay, done. Let's create the game with build-up fleet and alias, just the same as the first video in this playlist. The only thing that is different is that we create 5 EC port settings here. The first one is 777727781 UDP port for dedicated game server. because we have 5 concurrent processes. The next two is 19302 TCP and UDP port. It's used for stun server. It supports both UDP and TCP mode. The next two for turn server. It supports TCP and UDP mode as well. Now, the fleet is active and online. We need to test our stun turn server to make sure it runs well inside the fleet instance. We will use a website which is called Trickle Ice to test the stun and turn server. We will post its link in this video description. You can see how we construct the URL for stun and turn server in the example project. Let's do the same thing in Trickle ICE. We can get the IP address of the fleet instance from a pre-created game session in Game of Console. We have already run a PI client to test the fleet before we record this part, so there is already a game session. Copy the IP address to Trickle ICE. And combine it with the stun turn server port. Add server and gather candidates. If there is an S or FIX record, it means the stun server is running well. Thank you for watching. Please hit subscribe and like button. Thank you.